I was telling Gaetano beforehand, last time I had a talk about management, and I still was an engineer. Now I'm a manager, so I will present some really geeky topic about something which really is on the metal. This talk is not about Ivan. We are a multi-cloud data provider, but what happens in Ivan is that we use Python quite a lot. So that's why this talk was born. And what we use in Ivan is a monorepo. Monorepo is a great idea, in my opinion. But what happens is that we are at a startup. Now it's a scale-up. This monorepo was started in 2015. But then the company grew, and grew. Nowadays, we are about 200 between developers and SREs, so 200 people that work on this monorepo. And when this was started, everything was fine, and the monorepo was started with code which was essentially untyped, so no type annotation on it. You may know that MyPy officially started in 2012, but I don't know if somebody started using that at that time. I think it started getting traction around 2019, 2020. I don't know if somebody tried to use it beforehand and found some benefit to it. But let's put things in perspective. So those are the stats for Ivan Core. I don't know if you can guess what those numbers are, but I will tell you. So this is the file count. This is the blank lines. Maybe you don't care a lot about this. This is the comments, and this is the number of actual code lines. For comparison, something like Ansible is about 1/10 of this, and Django is about 1/4 of this amount of lines. So as the company grew, we started having some problems, and sometimes just importing code and running code from other directories in the monorepo created errors at runtime. Of course, you can write unit tests, you can write integration tests, but sometimes for something really silly, you would say, hey, no way this can work, so I would get an error in my test immediately, but on the contrary, you will discover it only at runtime, because the code was completely untyped, not time checking. So we started with the idea. The idea was, hey, let's start annotating our code. And then we do some checking of those annotations. But we wanted to do this, of course, as you might suspect, without stopping the world. So there was no chance of saying, hey, for 2 months, we don't develop on our product. We just annotate, then we have everything type checked, and they, oh, wow, we've won. That's quite unlikely to happen, and nobody will love you for this. And so, in your opinion, did this work? Yeah, exactly, sort of. The problem that we found quite quickly is the target. When you have a progressive annotation approach, is that the target is always moving. How? Let me explain this. So just a small recap of how MyPy works, okay? So MyPy usually starts in what I call lenient mode. So basically, if something is annotated in a file, then it's type checked. If something has no annotation, then it's not type checked. More or less, don't look at me in a bad way. There are tons of options that you can configure in MyPy. So it's not like, hey, MyPy, check this file is either lenient or strict mode. There are tons of options. The usual setting for this is per file. So you can tell to MyPy, this file is type checked, this file is in lenient mode, this file is not type checked. And MyPy itself, during the time we did this work, moves. So MyPy was still at 0 point something, and every new version, every new release changes something. Maybe they introduced a new setting. Maybe they changed the way a setting worked. Maybe the strict mode was different. Or maybe they would type check or not type check something that beforehand was not supported. So when I discuss the amount of options, okay, this is just a page for all the possible options in MyPy. Okay, so basically, okay, quite long, okay, just in case you didn't trust me, okay. So what we did was start with something like this, okay. So we created multiple sections in a MyPy configuration file, and we said, okay, for some modules, we want strict checking. So it means try to be as strict as you can when checking all the annotations with respect to what we provide. And for some other modules, be more lenient. Okay, so basically we had a configuration which allowed more errors to exist. And what we did, we tried, basically we started with more or less the whole code base in progressive mode. And we tried, so you went to a file, you added the annotations, and then you shifted that file, that module, from here to top. So the idea was start with everything in progressive mode and lift everything to strict mode. You can already see an exception in this configuration, which was necessary to make things work, because basically when you are in strict mode, MyPy does not allow you to call non-strict mode files, so we had to add an exception already. This is part of the problem that we will discuss later. But anyway, this approach had a problem. It's a horrible mess. Okay, so this was our first stage of grief, as they say. So we denied the problem, and we tried creating this file. But what happened? You must manually remember to shift files up. Sometimes you fix the typing, you put annotation, you forget to shift the files up. Somebody else does not realize the file is strictly typed, adds a non-annotated function or a wrongly annotated function, and then you are back to square one, and this is the moving target I was talking about. Your default cannot be strict, and you end up with a very, very long mypy.toml, because although the file allows wildcards, what happens is that if you just fix one file, you shift it up, and in the end, your mypy.toml is very, very long and difficult to maintain. So that's the reality. You can't just type check one file after another and believe that at one point you will get to full strict typing on a large code base. And so we get to our second stage of grief, which is anger. Okay, we said, hey, let's use a leaderboard. This will push us to be the best. So we created a file which would take a look at the code owners on GitHub, take a look at how many files were typed, were strictly typed or progressively typed in our code base, and we said, hey, every week we will do this and show how teams are getting closer to their target. Which is great. It did sort of work again, until you hit diminishing returns, okay? Because what happens is that, yeah, it's cool to just have static typing, but usually you need to provide a business justification for this. So it must be useful. We don't annotate files just for fun, just to get a higher score on the leaderboard. And what happened is that we started having some problems, and I think even one production incident, because we thought that some code was statically checked, while it wasn't, because we were using a mix of lenient and strict type checking. So we spent a lot of time adding annotations, quite a few issues, and so yeah, we realized that full static checking is great. Partial is okay, but if you have an unknown static checking status, that's bad. So it's you believe something to be working and already checked when it isn't. You forget, you ignore a unit test because you say, hey, this cannot work if the checker is at work and the checker is not working. And then we discovered some more problems. Maybe you were younger one day, you were programming, I don't know, in Java, in C, something, and you get something like, you know, an error while compiling. And you're young, and you think you know more, and you say, hey, the compiler is buggy. Did anybody say that? And then somebody older than you comes to you, and what they say? The compiler is always right. Is that true? What we discovered with MyPy is that the compiler is always right is not always true. So MyPy can be wrong or buggy, or maybe it does not support yet what construct you are trying to check, which led us to stage 3 of grief, which is bargaining. Okay. So this is an example of something that could not be type checked until some months ago. I discovered that the latest version of MyPy can actually check this. So in this case, MyPy was inferring object for this T, and so it was impossible to use this construct. This is an approach which is quite often used in Java. Now it works, but I kept the example because it was written already. And the additional problem is how to deal with serialization and deserialization, because a lot of time when you use built-in libraries, like JSON as an example, you get this construct. This construct yields non-annotated code, so you are forced to put something here, otherwise the code will not compile, will not be checked, my bad. But as you may imagine, at runtime, nobody cares about this. Okay, so you have a problem between what can be checked at compile time and what you get at runtime. Effectively, this one is very similar to a cast in this context, because if the function is annotated, then MyPy will complain about this. If this function has not an annotated return type, then you cannot. Then this thing is quite close to a cast. So MyPy can check very little. And there are more problems we discovered, more problems with runtime versus compile time checking. With data classes, here you have types, but again, this is not something which is enforced by Python itself. If you combine those issues, so if you combine deserialization with data classes and so on, you see you have a problem. So what is the point of type checking in a static way if then there is no guarantee that this type holds true at runtime? So this led us to our fourth stage of grief, depression. It seemed to be a very difficult problem to solve. But we have one more villain. So far, I have discussed only about annotations, but I'm sure there is somebody in this room who can tell that there is one more problem, which is not just unannotated code. There is code that can be annotated, but still do something quite bad to your code base. Any idea? Do you know about this one? Okay. At the beginning, we actually didn't. Well, we knew, but we thought it was kind of acceptable to retain this in many parts of the code. But what Any actually does is disable type checking even in strict code. So if you do, imagine that this is strict, okay? This returns any, and this happily passes your type checking. So any is really a kind of wildcard which must be used sometimes wisely, but if you have an any, even if your module is strictly type checked, you have a problem that could explode in your face at runtime. So at this point, we got to the fifth stage of grief. We accepted that there was a big problem, and we tried thinking about how to improve the situation without doing smart things or geeky things. And we devised one of our cool pieces of code. So this is available in an open source repository, which will be shared to you at the end of this talk, which is small, most strict configuration for MyPy with inline ignores. What does it mean? You get strict typing in your configuration, so you can get mostly strict typing by default in your MyPy configuration, and you get an inline ignore for a specific error only on a specific line. So this is a way for MyPy to disable a check only at one specific point. what does the script do is basically it parses your whole code base and uses MyPy on all those lines, picks the MyPy errors, and enables and puts this annotation, this comment annotation, only on that line. Then you can switch your configuration to a strict one and just have those comments in your code. So we actually did stop the world, but for just like 1 hour. Okay, we created this big commit with all these fixes. We put it in. At that point, it's very unlikely for anybody to be able to add an additional, to be able to add anything additional which is not strictly typed. You can actually change your leaderboard and not count the files, but count the instances of those type ignores for each team. And generally speaking, it's very easy to understand what is type checked or not, because you don't get a file and you don't remember what it is, but usually you are in a file, you know it's strictly checked, and then you have this ignore. This is very, very self-evident. You don't need to reach out into other parts of the code base to understand what the heck is happening. About MyPy bugs, our choice was not to fight them. So what happens is that you need to accept that you may need to change your code, not just to annotate it when fighting a MyPy bug. So you may need to shift your statements around, change the way your code is written, until you get to a version which can be statically checked. And if you don't want to change too much, or you still have problems, you use something that I usually call runtime check for a cast. So instead of using a cast, what we did, even for deserialization and annotation issues, is using a kind of guard before or after the annotation. So what happens with MyPy, I think it's well understood, but I don't know if it's everywhere. So if you do something like this, so if you check for an instance of type, then after this, MyPy will have inferred the type as string. But this is an actual runtime check. Okay, so if you really write this code, of course, you cannot check this at compile time, but this is something that can be loaded at runtime. Okay, here we have a string just for the sake of an example, but probably this will come from an external call, HTTP, any file, anything. This way, you have a code, at least you know that you will get an error in the right spot instead of propagating the mistake in your whole code base. You can adopt the same approach when you use an external library. This is something that I haven't discussed so far, but sometimes your external library is not annotated. What is a good practice is to try to type check the external library, let's suppose it's JSON loads, as soon as you use it in your code. And remember that using a cast or a type annotation is still more risky, because if you have an external library and you say, hey, but I see that this method always returns a string, so I can just annotate with string. What we say is no, because you are probably totally right here, right now, that it returns a string. But tomorrow, you will update your dependency, maybe the return type changes, and then you have a lingering bug in your code. So if you're integrating with a third-party library which is not annotated, please make sure to do this kind of check instead of just putting a cast or an annotation on your return type, and it will prevent to you a lot of not so fun errors that can happen in production. But I'm sure that for the deserialization part, somebody will say something like, I know how to solve this. So how would you make sure, or at least be reasonably confident, that when you deserialize something from, I don't know, JSON, string, whatever format, the class in Python has the right types? Validation. Yeah, well, validation, but pydantic was, yeah, my answer. And that's true, it's a very good answer. What we discovered is that pydantic can have some dark corners, we didn't know about at the beginning. So Pydantic has a lot of configuration as well, a lot of ways to work. The main problem we found is mind your types. So what happens? You have a code base, it's 5 years old, you have done everything without checking the type at any time. Then you run mypy or you run typing reveal to check what is the actual type that is being returned or accepted by a function, and you get something like this. Okay? That's extremely typical. What happens is that it's not obvious what happens with Pydantic when you try to parse a union. If I remember correctly, with the last version I tested, with the configuration I tested, so I can be wrong, don't take my word for this, is that Pydantic tries to use the first, like the types in the union from left to right, so, and does a bit of coercion with the default configuration. So if you try to parse something which fits a string, then this will be a string. But maybe when doing your, when creating your types, you have switched int and string. So for a type, which from a Python point of view is more or less identical, so you just switch string and int, you can get different parsing for Pydantic. So what we recommend, because this can be quite a pitfall, is get your types together before using Pydantic for this realization. Okay, so first you fix this, so you have a types that make sense, and then you start using Pydantic. Trying to do it at the same time can be, we usually say fun, but that's not what you may mean for fun. So, getting back to the final question. So, would we do it again? So, would we start again with this approach? We haven't finished it yet, but a large part of our code is now checked. And my answer is definitely yes. But there is a last answer, the last question, sorry. So, would I use again a non-statically typed language to begin with for such a large code base? My answer is maybe. It depends. But for sure, if I think that this could be the road where you're going to, I would at least consider using something that can be statically checked to begin with, and does not bring us in this realm of a bit of madness. So, I'm done. Thank you.
Thank you very much. Very great talk. Now we have some questions. Okay. Okay. Did your team consider using another type checker, and why did you settle for MyPy?
Another type checker, you mean PyWrite, something like this? I must admit that I was involved with the initial decision of using MyPy, and so I'm not aware of any kind of check during the time when you tried evaluating the type checker. I think, I haven't written this here, but I think it's part of the problem. So, first thing, you want to type check something, and you already have the choice of 2 type checkers. Well, while in Python Zen, there should be preferably one way to do it. So, no, and I think it could be the 6th stage of grief, if it was something like this. So, think about what PyChecker we could use. We just wanted to stay as close as to the reference one as possible, I believe.
Okay. How about Athrs versus Pydantic? Athrs, the library.
I must say that I have used it in the past, but I haven't tested it in Ivan Core, so I don't have any kind of answer for comparing the two. What are the different trade-offs? If it works, so now you know the problems. If it works with the kind of use cases I presented, use Athrs.
What is your take on an hypothetical Python 4 being statically checked?
Okay, so I was here, probably not physically here because we were in another hotel, when there was a transition between Python 2 and Python 3, and I hope that, I think that Hido himself said, hey, we won't do anything like that anymore, and I hope it won't be done. So I don't want anything to be broken at, for a long period of time or having two different versions. I think the problem is making everything type-checked and all the libraries type-checked. So I don't know if we need an actual Python 4 with this enabled. If it is impossible, if it is desirable, maybe if we can have a reference MyPy configuration and kind of convince all the libraries to publish strictly checked code, that would be enough. Because the problem now is that you must depend on some non-annotated code, because as long as your whole chain is not annotated, then you're kind of lenient, okay? You still have some room for problems. So I would not advocate for a breaking change. If we can do it in a progressive way, so we get Python 3.100, which is statically checked, could be an idea, but I don't know if there is a performance impact or anything like that.
Okay. MyPy takes a very long time to check our code base, and MyPy crashes. Any tips for speeding up the checks?
There is a way to compile a wheel, if I remember correctly. If it crashes, I don't know, you restart it. This is something that happens to us as well. It is true that MyPy can be slow at times, so sometimes we were joking that I think we did a comparison, and it could be that we could compile a code, the compile time of a Rust code base, Rust, is more or less equivalent to the check time of MyPy for our full code base. So this kind of negates part of the advantage of Python. Hey, you don't need to compile it. I think it will get better, but it's still a bit an in-progress piece of software. Maybe we will write it in a lower level language at some point.
Okay. Can the type guard create performance issues? Isn't instance fast? Can the type guard create performance issues? Is instance fast?
I must say, maybe it's a performance issue, but with the kind of job we do, reliability or correctness is more important than performance. So I must say, I did not benchmark that, and usually I don't care. I don't want to have performance at the cost of issues.
Can't we just use assert on all the lines we think must be strictly checked?
So you could, and the compiler realizes that, but as any seasoned Python programmer will know, if you specify an optimization level in your Python compiler, then assert is ignored. You can do that, but I wanted to show you the most correct way of doing it, which is always working. Just this. But otherwise, it's okay. Remember that assert could be not working at runtime if you disable it at any time with an optimization level.
Okay, last question. With runtime checks, is it not postponing the risk at runtime?
Could you repeat the question?
With runtime checks,
yeah.
Is it not postponing the risk at runtime?
Of course, but if you are deserializing something, well, you cannot statically check what somebody is sending you from the other side of the wire. So you should try to make sure that bad types don't enter your code base at an unexpected moment. But the deserialization moment is usually the moment where this can happen, and you can handle it in an expected way.
Okay. Have you tried using typeguard, the library, for runtime checks?
I think we tried, but I don't remember why we didn't make it into our code base. I'm sorry about this detail. I forgot. If we can If you like, I can take a look, drop me a message on LinkedIn, and maybe I will answer about this as well.
Okay, we have no more time for other questions. You can speak with Alex right here. And I want to thank you for this wonderful talk. So applause for Alex, please.